Okay, we're going to talk about anticipation. Now, this is probably going to be a fairly long struggle here for something that actually works very easily and very simply. Normally in a thermostat, a mechanical thermostat, and by that I mean something like that. Mechanical in that it has a lever on top and it moves back and forth and controls temperature. All thermostats have what we call lag and overshoot. As the temperature drops, the bimetal is going to move. We're talking about heat here. However, it takes time for that to happen. The conditioned space temperature may drop, but the temperature of the thermostat may not drop, so the bimetal doesn't change, so it doesn't turn on the heat or turn off the heat. So it takes a little bit of time, which means it gets colder as the time goes on. So let's take a look at a standard thermostat without anticipation. Now we got temperature, we're set for 70 degrees. Okay, because of heat loss of the structure, the temperature is going to drop. Well, we'll figure the lag on this thing to be about 1 degree Fahrenheit. So when you hit 69, it comes on. The furnace comes on. Now, most furnaces do not immediately produce heat. It takes up to 2 minutes before they start. Some much longer than that, but they have to warm up, then their fan comes on. Okay, immediately when the fan comes on, that does not mean the heat in the house warms up. It has to fill the ductwork, warm the ductwork, start air currents moving in the house, and so you've got more lag there, so the temperature is continuing to drop down to this point. Now, it's not a straight line, but I did it that way because it's easier. But as it goes down, it's eventually going to start coming back up again because the furnace is on and it's warming the structure. So it warms the structure, warms the structure, warms the structure. It gets to about 71 degrees Fahrenheit and shuts off. Now here again, the furnace does not stop heating right away. It has to cool off its heat exchanger and so on, so it continues to rise to say 72. Then this whole cycle starts over again. Well, if you look at this, you can see we went down to 68 to 72. That was the variance in our temperature of the structure. That is a pretty noticeable temperature change. Most people can feel 3 degrees Fahrenheit, some much closer than that, some 1 or 2 degrees Fahrenheit. So what the people in the structure are going to notice is that it gets hot and then it gets cold. Hot, cold, hot, cold. There is no way to get rid of the mechanical lag in these thermostats. It's just a question of the physical limits. So we come up with a really cool idea, and I sure as heck didn't really come up with it, but it did get comed up with, and I'm going to show you what it is. So the solution that the industry came up with for this problem, the problem is also, I should go over this before we get any farther, there is lag, as I said before, and there is overshoot. Lag means it's slow to come on. Overshoot means it's slow to shut off. So those two terms are one of the things we use here. Okay, here's a mechanical thermostat, and there's a part inside. We call it the Anticipator, and there it is. That's that round dial. Now these things can be any place. Well, not any place, but they're not all this obvious. I'll show you one that's not so obvious a little while later. Notice that dial goes from 0.15, which is way down there, way there. Okay, to 1.2, which is right there. Okay. That little wire is the anticipator. And there's a wire coming through the thermostat here, connected here, and going around clear over to here. And the bimetal is right behind here. So it's going to warm the bimetal. So what the result of that thing is going to be is when the unit is on. Now this heater is only energized when the unit is running, when the furnace is on. So it starts warming as soon as the thermostat calls for heat. What that's going to do is bias the thermostat, meaning it's going to shut it off early. Instead of it shutting off at say 71 degrees and then overshooting from there, it shuts off at say 70.5 degrees, anticipating that the structure will be warm. So it shuts off early. The temperature continues to rise in the structure as it normally would, but it won't rise as much. Then, when the unit shuts off, that heater shuts off. So when the heater shuts off, the bimetal goes back to sensing the temperature in the room, which means it's going to turn on a little bit early. So on a little bit early, off a little bit early, thereby smoothing out the temperature changes in the room. Okay, here's an illustration of how a anticipated thermostat would operate. As the temperature drops, the furnace will come on a little bit early. Because remember, this little heater in there, that anticipator heater, is shut off. So it comes on a little bit early. That modifies this a little bit, doesn't go down as far. Then it starts going up, and then at about, say, 70.5 degrees, it shuts off. So it doesn't climb up way to here like it did. And it smooths out the cycles. That's what that anticipator is all about. And it will hold, if a good anticipator on a mechanical thermostat will easily hold 1 degree plus or minus, and very commonly will hold more like a half a degree. They can be that close. So that's why we use anticipation. Shuts it off early, turns it on early. Shuts it off early, turns it on early.
And in the next video, we're going to take a look at how to adjust the anticipator.
How to adjust it.